Here's a question I'd like us all to think about as we go through the contents of this video. How would you recognize a machine learning based system if you saw one? So let's say you were shown a piece of software or a system. How would you know whether it makes use of machine learning or not? What are the defining characteristics of a machine learning based system? Hello, and welcome to this module on understanding the foundations of TensorFlow. In this module, we are going to segue just a little bit away from pure Google Cloud Platform related technologies because machine learning is an incredibly important set of algorithms for the future. TensorFlow, which runs on the Google Cloud Platform, is heavily tested in the certification tests, and to a large extent, it is also a differentiator of the Google Cloud Platform versus competing cloud offerings such as those from AWS or Azure. Now, that's not to say that Amazon or Microsoft don't have their own formidable machine learning offerings. They do. But rather, it is because TensorFlow is fast becoming a tool of choice for certain machine learning applications, particularly those involving deep learning or neural networks. So, one can plausibly argue that TensorFlow is something which the GCP offers natively that is highly sought after on every platform. In any case, with that preamble out of the way, let's move into an overview of the territory that we are going to cover. TensorFlow is a language or a library for numerical computations, and by far its most common and important use is in machine learning, specifically in building deep learning and neural networks. We shall see why TensorFlow is slowly or quickly becoming the default library of choice, particularly for deep learning networks. And we'll do all of this after a quick primer on what machine learning really is and how it differs from alternative approaches. Machine learning is gaining in popularity for many of the same reasons that cloud computing is. It lies at the convergence of two trends. The first is that data sets are getting bigger and bigger, and the second is that the world is getting smaller and smaller, meaning that interconnections between data items are becoming more pronounced and more important. And that is what machine learning really specializes at. The whole point of machine learning is, given a large amount of data, infer relationships between those data items. So the typical use cases of machine learning involve working with a large data set, searching for patterns in that data set, and finally making intelligent decisions based on what's in there. The whole point, the defining characteristic of machine learning algorithms is that they change their behavior based on the data that they are operating on. This property, in and of itself, does not make a machine learning algorithm any more complex or more sophisticated than a traditional algorithm, which is based on static rules. More on that in a moment. So, this is an important definition. Keep this in mind, really internalize this fact. Machine learning algorithms are those which alter their behavior based on the data that they are working on. In a sense, they are learning from the data. Let's consider a simple use case for machine learning. Let's say that you have a large number of emails and you would like to classify these as either spam or not spam, that's known as ham. Now, this certainly is a problem for which you could use machine learning. You could also choose to solve this problem without machine learning. In fact, for the longest time, email classification was carried out on the basis of static rules. If an email originated from a particular IP, it would be treated as spam. If an email contained a certain set of words, suspicious words, it was treated as spam, and so on. Of course, the problem with this static rule based approach was that spam providers were very fast. They were quick on the uptake. They'd keep changing their behaviors. They would start sending emails from new IP addresses, or they would introduce typos into those sensitive words. And that's not all. Very often, the same IP addresses were those of mail service providers, which also sent out legitimate emails. And for all of these reasons, the static rule based approaches tended to give substandard results. The most efficient way to keep ahead of the spammers in this arms race between spam and legitimate email was to switch to machine learning. Machine learning applications would then search for patterns in spam emails. As those patterns changed, the way in which those machine learning algorithms carried out that classification would change also. And in this way, machine learning algorithms have become the standard for spam classification. And the outcome of this classification process is a decision, of course. Should that email go to your trash can or to your inbox? This is important. Machine learning algorithms take in a large amount of data, which could be emails on a server. They process that data in some way, for instance, looking for patterns associated with spam emails, and then they typically make a decision of some sort. For instance, whether that email ought to go into your trash can or into your inbox. Machine learning algorithms have gotten more sophisticated, and so have the problems to which machine learning can be applied. You could equally treat an image as a large dataset, a dataset of pixels. The machine learning algorithm might then identify edges, colors, and shapes that might give it enough information to classify the photograph as being of that of a little bird, yes or no. We should mention here that in some of these complex learning algorithms, machines are still very far behind human beings. There was this study, a famous study some years ago, which showed that only the absolute cutting edge technology in machine learning was able to identify a video which contained a bear. On the other hand, this is something that a 3 to 5 year old human child was able to do with virtually complete accuracy. And it is precisely in these complex machine learning applications that TensorFlow really shines. In many ways, the starter hello world problem in TensorFlow is that of image classification. We'll get there, but before that, let's just continue with our survey of machine learning for a little bit. Machine learning has tended to be used for a specific set of problems. The first of these is classification, the second of these is regression, the third of these is clustering, grouping together similar points in a high dimensional hyperspace, and the last of these is rule extraction. Given a large set of data, find if else relationships. We are going to implement 3 out of 4 of these categories using TensorFlow. Let's keep going for now and understand some of the conceptual underpinnings. Let's start with classification. The email classification problem, spam or ham, was one example, but let's now try and understand what makes a machine learning approach different from a rule based one. Let's come back to the question we posed at the start of this video. The defining characteristic of a machine learning based system is that its internal operations, its internal working, change in some way based on the data that's been fed in. Take, for instance, a linear regression algorithm. Here, there is always going to be a straight line that's going to be fit to the data points you feed in, but the equation of that line is going to change based on the data points you pass in. By contrast, let's say you had a system which had been prepared by an expert. That would not change its inner working based on the data fed in. The equation of the line would be independent of the data fed in. This is the telltale sign. This is the defining characteristic of a machine learning based system in contrast to a rule based approach.